Okay, so the next topic I would be covering here is programming for cutter compensation. And we'll learn about what cutter compensation is and how this works in 2.5-axis operations. So I have a slide for cutter compensation, and then I'll go through a demonstration of how the cutter compensation works in our CAM products. So cutter compensation is used to compensate typically for tool wear, uh, to compensate between the actual tool diameter to the program tool diameter at the machine or the controller. And the cutter compensation is typically output using a G41 to comp on the left, or a G42 to comp on the right, and a G40 is used to cancel cutter compensation. Now, in the following slide here, you'll see we have a profile toolpath for illustration of cutter compensation. The cutter compensation is output on the first linear move on your entry. So in the sample output code, you'll notice that there's a G41 right after your plunge move. At the beginning of your first XY move, you have a G41, a cutter compensation that's being, it's turning on the cutter compensation. And at the very end, before your departure move, it's canceling the cutter comp with a G40, and then you have your departure motion. So after the retract, before the departure move, you have a cutter compensation cancel. So in this case, it's outputting comp left. If it was a cutter compensation right, instead of a G41, you'd have noticed a G42 in here. Now there's a few things that I would like to point out for the cutter compensation to work. Number one is your cut direction needs to be set to either climb or conventional. Setting it to mixed will not be able to output cutter compensation. Also, when you're specifying entry and exit, you would need to specify linear entry and linear exit in order for the cutter compensation to work on your machine tool. In addition to these, you will also need to enable cutter compensation in the cut parameters tab, which I will be demonstrating here in just a moment. So I'm going to switch back to RhinoCam to cover cutter compensation. And I'm going to take a look at the 2.5-axis profiling example in here for cutter compensation. So as I edit the operation, I go over to the cut parameters tab, and under compensation, we have the drop-down menu. So selecting to auto none will still compensate, the toolpath still compensates for the tool geometry when the operation is programmed. As you can see here, we're using a 1/2 inch end mill, and the toolpath is compensated by the tool geometry. So in this particular case, there is no cutter comp being output in the posted code. Now, setting the compensation to auto on or control on will still compensate for the tool geometry, and in addition to that, it'll also output your cutter compensation code, which could be a 41 or a 42 depending on your compensation right or left. So we need to make sure that the cut direction is either set to climb or conventional, and under entry and exit, we also need to make sure that the entry is set to linear motion under engage motion, and the retract is also set to linear in order for the compensation to be applied. So I'm going to pick generate, and one of the ways you can verify even before you post process the code is you can go into your toolpath editor / toolpath viewer, and you will notice that right after approach motion, you'll see the cut comp left, which is enabling the cutter compensation in here. And I'll toggle off the display of the tool holder, so you can see that the toolpath is still being is a tool geometry. In addition to it, it's outputting the cutter compensation. And right after the departure move, the cutter compensation is being turned off. So as I post-process this toolpath, and since we have multiple levels programmed in here, the cutter compensation is turned on for each of the cut levels. You have the G41, and then it cancels out with the G40. This would be for the first cut level. And for each cut levels, it's turning it on, the compensation, and turning it off. Now, in the case of a pocket operation, the cutter comp is turned on automatically in the final pass. So when you specify your cut direction to climb or conventional, and you specify a linear for the engage motion and generate the toolpath by toggling on the cutter compensation, it'll automatically output the compensation on the final pass for each of the cut levels. So when you post process it, you will see the cut comp being output in the posted code, and you can also notice the same over here in the toolpath where you can see the cut comp is being turned off at this particular level at the final once at the exit motion. So the cutter comp can be applied in several of the two-axis methods: pocketing, profiling, chamfering, filleting. The only operation where there's no cutter comp would be typically engraving, and also hole pocketing and hole profiling, since these two methods also involve a z-axis motion as it ramps into resulting in a helical motion. In the case of engraving, the tool remains on the geometry, so there won't be an option to turn on the cutter compensation. So this gives you an overview of how cutter compensation works in our two-axis operation.